This is 4142 practice. If you guys are asked to convert from radians to degrees or degrees to radians, what is the conversion factor that we talk about? What's the conversion that we talk about? Or 180 over pi. Okay, I'm not going to tell you guys convert from degrees to radians or vice versa. You need to figure that out. If it says to keep your answer in terms of pi, you don't have a calculator. I'm not asking you to multiply your answer by 3.14. Leave the pi in your answer. So if I start off here 45 degrees, that means I'm going to what? Radians. So my conversion would be what over what? Pi over 180. Why is the 180 degrees in the denominator? So the degrees will cancel out. Okay, so you guys are going to have to simplify. You might have to write down some numbers and do some basic division. That is expected. These are very straightforward questions. You need to do this correctly. I'm not going to go through and give you partial credit because you don't know how to do division. So what number goes into both 45 and 180? 5, 9. What do you guys want to do?
9.
Okay, 9 goes into 45 how many times? 5. How many times does 9 go into 180? 20? Okay. Can I simplify more? Yes. 5 goes into 5 how many times? Once. And 5 goes into 20 how many times? 4. So my answer here is pi over 4. Could I also write it as 1/4 pi? Yes. Questions?
You don't have to put radians at the end?
If I'm starting off in, I go to, there we go, so pi over 180. So my zeros will cancel out. What number goes into both 30 and 18? 6. 3 does, but okay, we see 6. So 30 divided by 6 is 5. 18 divided by 6 is 3. What do I have? 5/3 pi. 5 pi over 3, however you want to look at it. If I'm going too quickly, let me know. I'm just assuming we're good. Guys, I have a negative sign here. What does a negative sign in front of an angle tell me? Let's go with the direction. All right, that does nothing for our calculations. I'm still in degrees, and I'm going to where? So I'm just going to put my 180 on the bottom here, pi on the top, and I'm going to rewrite my negative sign. If you forget your negative sign, your answer is incorrect. There's a huge difference between positive 225 degrees and negative 225 degrees. What is so comical? Do share, please. We can put it on the video so then everyone can know. Okay? Yeah. What goes into 225 and 180?
5.
Okay, 5. Anybody going to tell me?
45.
Okay, 45 and
36.
36. Okay. Can I simplify that more?
9.
Okay. 9 goes into 45
5.
and 9 goes into 36. So I'm left with
5.
negative 5 pi over 4. We good? All right, moving on down. What am I starting off with here? Radians. That means I'm going to.
Degrees.
Yes. So what's my conversion look like?
180 over 5.
Good. 180 degrees over pi. So right away my pi's do what? Cancel. Good. Can I cancel anything between 6 and 180?
Yes.
6 goes into 6.
Plus
6 goes into 180.
30.
What is 30 times 11? 330 what? Degrees. Make sure you have your degree marker. Whoops, I covered up the denominator. This is 7 pi over what? 3? Okay, thank you. So I'm going from what to where? Radians to degrees. So my radians on the bottom, my pi on the bottom, degrees on top. What happens to the pi's? They cancel. What about 3 and 180? 1 and 60. Great. So then I'm left with how much? 420 degrees. Okay, questions? They were trying to find positive and negative coterminals. We're going to add a whole circle. We're going to subtract a whole circle. If I'm in degrees, I'm going to add and subtract what number? 360 degrees. If I am in radians, I'm going to add and subtract what? 2 pi. Okay, so this is fairly simple if we're just in a degree measurement. If I have negative 125 plus 360, what do I get? 235? Do we agree? Okay, so there's my positive, and then I'm going to set negative 125 minus 360, and I get what? Negative what? 485 degrees. Okay. Right, over here in our phantom problem that I covered up, what was it? Thank you, 11 pi over 7. I'm going to add 2 pi. Can I just add those two together just by staring at it? No. Common denominator. What's my common denominator between 1 and 7? 7. If I change 2 pi to sevenths, okay, I'm going to multiply the bottom by 7 and the top, so I get 14. So what is 11 plus 14? 25 pi. There's my positive. Now I'm going to do what? Subtract. So 11 pi over 7 minus 2 pi. Again, guys, common denominator is 7, right? So 2 pi over 1 becomes 14 pi over 7. Good. So 11 minus 14 is negative 3 pi over 7. We good? Yes? Okay. Now let's talk about complements and supplements. First of all, when I say the word complement, what do you think of? What number? 90 what? 90 degrees. What is that in radians? Pi over 2. Good. When we talk about supplement is 180 degrees or pi. Depending on the degree measurement or the radian measurement, that's what we're going to use. Guys, it's always going to be 90 minus 180 minus. We're finding two positive angles that add to give us 90 or pi over 2. Two angles that add to give us 180 or pi. So when I do this, when you guys are showing me your work, it's real simple to do. Finding the complement and the supplement to 104. So I'm going to say 90 minus 104. It's negative something, so what's the answer for my complement? None. Don't write 0. That's a number. Don't leave it blank, and I'm supposed to just assume that you meant, oh, there's no complement, something like that. So make sure you guys show me what you're thinking, and then tell me there's none. So to find the supplement, I'm going to take 180 minus 104, and I get what? 76 degrees. Same thing with 37. 90 minus 37 gives me 53 degrees. 180 minus 37 gives me 140 degrees. You guys want me to give you like 20 of those, right? Yeah, no. All right, now we come over here and we have to use fractions and we freak out a little bit. Guys, when I'm talking about complements and supplements, it's pi over 2 and pi. It needs to be pi over 2 minus. Pi minus in order for you guys to get this correct. So I'm going to say pi over 2 minus 3 pi over 4. I have to get a what first? Common denominator. Common denominator between 2 and 4 is 4. So if I make this 4, my top becomes correct. What's 2 pi minus 3 pi? What does that tell me? None. No complement. Like choking over there. All right, what about here for B? How do I find the supplement? Okay. So pi minus what? 3 pi over 4. Whoops. That's a pi. I need a common denominator, which would be 4. All right, if I change pi over 1 to fourths, what does it become? 4 pi over 4. Good. So 4 pi minus 3 pi is? Pi over 4. Yes, sir.
So for those, would you want us to leave it like in terms of like in radians, or would we have to convert it to degrees?
No, if you start off in radians, stay in radians.
Okay.
All right, let's look at the next one. Pi over 6. I have pi over 2 minus pi over 6. Common denominator is 6. So this becomes 3 pi over 6. What's 3 pi minus 1 pi? 2 pi over 6. Can I simplify?
Yeah.
Becomes pi over 3. And then we have pi minus pi over 6, right? Common denominator of 6. So this becomes 6 pi over 6, right? So 6 pi minus 1 pi is 5 pi over 6. Good. All right, how are we feeling so far? You guys okay? All right, let's pay close attention to these next few, because these are the ones that are a little more difficult. It says find the arc length of the sector given the information. So arc length, remember our formula is S equals R times theta. I'm not giving you that, you need to know that. What do we know about our theta? It has to be in what?
Radians.
Has to be in radians. So what do I have to do with 225 first? I have to convert it. So if I convert 225 and 180, what goes into both? 9? 5? What? Okay, 5. 5 goes into 225 how many times?
36.
No.
No, 35.
45?
Yeah.
5 goes into 180 how many times? 36? More?
Yeah, and divide by 9.
9 becomes
5 and 4.
5 and 4. So I have a radius of 6 and a theta of 5 pi over 4. If I'm asked to find the arc length, we say 6 times 5 pi over 4. You can simplify now. You can simplify at the end. If I multiply across, 6 times 5 is 30 and 30 pi over 4. Or you can simplify inside. It doesn't matter, but you have 30 pi over 4. What does that reduce to? So 15 pi over 2. That's our arc length for that one. If I was going to do this one, what do I have to do first? Okay, we're going to convert. What happens with 120 and 180? Zeros cancel, then what? Okay, so this becomes 2 and 3, so it's 2 pi over 3. So I have 3 times 2 pi over 3. Cancel out the 3's. My answer is? All right, if I come down here, there's a couple things I want you guys to change on your problem. I changed the problem a little bit on the quiz. Instead of finding the radian measure, I want you to find the degree measure. It's going to be one extra step, so change that on your problem. And then make sure your S, your arc length, has pi with it. So it should say S equals 8 pi, and it should say S equals 48 pi. You'll see why in a second. So if we're talking about arc length, remember, the formula again for arc length is S equals R times theta, correct? Well, what did they give me in these two examples? They gave me S and they gave me R. I'm trying to find the central angle. So for this first one, I would say 8 pi equals 6 times theta, because that's my radius. I'm trying to find theta, so what do? Divide both sides by 6. So theta equals 4 pi over 3. How do I want your answer? In degrees. So what's the extra step you need to do? We got to convert 180 over pi. So your pi's will cancel out. What happens with 3 and 180? Okay, so 60 and 1. What is 4 times 60? So your theta is 240 degrees. All right, same thing here. What did they give us? They gave us R and S. So they gave us that 48 pi equals 12 times theta. So what do I do? Divide both sides by 12. So theta equals, what's 48 divided by 12? So 4 pi. Is that in degrees? No. So if I multiply, right? Whoops. Ay, ay, ay. So I have 180 times 4, which is?
520? No, 720.
720?
Yeah.
720 degrees. All right, this is where I meant to put the unit circle. I don't know why I put it up there. So here's our unit circle. You guys will be given this completely filled out on your quiz. So you don't have to worry about it. All right. First thing it tells me is I want to find all 6 trig functions at what angle? 225. So on my lovely unit circle, 225 is, what's the ordered pair? My ordered pair is negative root 2 over 2, comma, negative root 2 over 2. So if I'm going to give you all 6 trig functions so you know exactly what I'm looking for. Sine is what letter? Y. Cosine is? Tangent is? Y over x. Good. Cosecant is 1 over y. Our secant is 1 over x. And our cotangent is x over y. Okay? So what is the sine? What is the y value of my ordered pair? Negative root 2 over 2. What happens to be the cosine? Negative root 2 over 2. There's no work that you guys have to show me for that. For this next one, you have to show me any work. If I did y over x, what's anything divided by itself? 1. If you want to write it out, that's fine. But you don't have to if you can just see it like that. For the next 2, 3, how do I find the cosecant? It's 1 over that. So in a sense, all we're really doing is what? We're just flipping it. So it's 2 over negative root 2. Can I have that?
No.
So top and bottom by root 2. Top and bottom by root 2, yeah?
Yes.
So this is negative 2 root 2 over 2. Cross out the 2. So this is negative root 2. Well, if my cosecant is negative root 2 and my cosine is the same as the sine was, what's my secant? Negative root 2. You guys can just do that. That's fine. And then if I have x over y, you can write out the x over the y if you want to show me. Or you can just say that the reciprocal of 1 over 1 is 1. There's my answer. Questions? You guys are getting the unit circle. All right, this is something I wanted to bring to your attention because sometimes we get this confused, so we need to really pay attention here. If the angle is negative, what does that mean in terms of finding where that angle is on the unit circle? It's the other direction. So find pi over 6. Where is it?
It's 1 space.
It's 1 space above your initial side. So in order to find the negative 1, you're going to go 1 space which way? Down. So this is the ordered pair that we're talking about. Root 3 over 2 and negative 1/2. So I'm going to write down root 3 over 2 and negative 1/2. Everybody agree with me? You guys good with that? So I know my sine and my cosine. What is the sine for this angle? Negative 1/2. Good. What is the cosine? Root 3 over 2. And then what's the tangent? Y over x, right? So negative 1/2 divided by root 3 over 2. Keep, change, what? What happens to the 2's? So I have negative 1 over root 3. Rationalize, what's my answer? Perfect. Negative root 3 over 3. So that's my tangent. So now you can look at these. Now you can take your 3 reciprocal functions and just work off of what you have. If I have 1 over 1 negative 1/2, what am I really doing with negative 1/2? Flipping it. So this becomes negative 2 or negative 2 over 1. For my secant, if I flip it, what does it look like? 2 over root 3. Can I have root 3?
No.
So I'm going to rationalize, and this is going to give me 2 root 3 over
3.
There you go. And then here, I can either write out x over y, or I could just flip 3 over negative. Or I can flip. Can I have root 3 in the bottom?
No.
No. So I'm going to rationalize. God bless you. And I have 3 root 3 over negative 3. What happens to my 3's? So I'm left with negative root 3. Questions? We're okay? All right. Let's look at the last one on this page. And then I'm almost done. Looking at the unit circle, folks. What is the ordered pair at pi? What is it?
No, 1 negative 1 0.
Negative 1, 0. This is not meant to be a trick question, guys. If you get this, please don't make silly mistakes. What is the sine of this angle? 0. What is the cosine? Tangent is what over what?
Y over x.
So it's 0 over negative 1, which gives me 0. Okay? The cosecant is 1 over the sine. So it's 1 over 0, which is undefined. What does web of sine say? Impossible. If I put 1 over negative 1, what's my answer? Negative 1. If I have x over y, it's 0 over negative 1, which gives me, just kidding.
No, yeah.
Yeah, I was thinking that. That's why I wrote negative. If I had negative 1 over 0, what does that give me? Undefined. Or impossible. Again, undefined-o.
Yes.
Yep, that's a new word I just made up. You can use it if you'd like. Questions on that? Are we okay so far? All right, let's look at the next. Questions about that?
Well, no.
Then we're done. All right, folks. I drew this lovely little picture on your notes. You need to know that if they talk about a clock and the rotation and all this good stuff, you need to know that a quarter rotation, the radian measure is pi over 2, and that the time is 15 seconds. You need to know if they say half rotation that we're talking about pi in terms of radians and 30 seconds. You need to know that if they talk about 3/4 of a revolution, it's 3 pi over 2, and our time is 45 seconds. And if it's 1 whole, it's going to be 2 pi and 60 seconds. Yes? All right, I also want you to change in this problem. Go ahead and change it to just 4, because you guys aren't going to have a calculator. So for easy calculations, I left it as whole numbers. I'm going to do all 4 parts of this problem, because everybody's going to have a different version. But what should all 4 answers be?
The same.
Why? Because why?
Because the hand moves at the same time.
Because the hand is moving around a clock at the exact same time. So it's important that you guys see this. So if I talk about linear speed is our radius times theta in radians over time. So if I talk about a quarter revolution, okay, we're going to set each one of these up separately. If I talk about a quarter revolution, my radius was 4 that I changed it to, correct? Yeah? Okay, a quarter revolution. What is that in terms of pi? It's right up on the board. Pi over 2. And how many seconds is that? 15. Okay? So if I'm going to work this out, guys, simplify the numerator. Can I cross cancel anything between 4 and 2? Yes. 2 goes into 2 once. 2 goes into 4 twice. So I'm left here with 2 pi over 15. Leave your answer in terms of pi. You don't have a calculator. So now if I'm going to do a half revolution, what changes when I do a half revolution? the time, and what else? The seconds, which is the time. What else changes? Do I use pi over 2 again? No, I use half of a circle, which is what?
Pi.
So I have 4 times pi over 30 seconds, correct? Can I simplify 4 and 30? Yes, becomes what? 2 and 15. So I have 2 pi over 15. That's the speed that the second hand is moving around the clock. If I come over here, if your version says, okay, I have a 4 centimeter radius and I'm going 3/4 of the way around the clock, what is the degree measurement? 270. So what does that equal in radians? 3 pi over 2. And then what's the time talking about? 45 seconds. Simplify the numerator first. What goes into both 2 and 4? 2. So 2 goes into 2 once. 2 goes in here twice. So I'm left with 6 pi over 45. What number goes into 6 and 45?
6.
Nope.
No, 3.
3. 3 goes into 6, 2. 3 goes into 45, 15. So we're left with 2 pi over 15. You guys see how we're getting the same answer every time? Because the clock moves, the second hand moves the same speed. So if I go one full revolution all the way around, I have a radius still of 4. My central angle, or theta, is 2 pi. It's the whole circle, and I'm going to divide that by 60. So guys, 4 times 2 is 8. So I have 8 pi over 60. What goes into both 8 and 60? 4. 4 goes into 8 twice. 4 goes into 60, 15. So you have 2 pi. Sure. So I have 2 pi over what? 15. Do you notice, guys, again, I'm saying this again, we got the same answer because your clock hand is moving at the same speed the entire way around. Yes? Okay, last thing I want to bring to your attention. Guys, do not say to me tomorrow, we never did a problem like this. If I tell you that the cosine of theta is 2/3 and the sine of theta is root 2 over 5, I want you to figure out all the other trig functions. Can you do that? Yeah, because what information did I just give you? I gave you x and y. What's the x value? 2/3. What's the y value? Root 2 over 5. And then you can figure out the rest. Okay? It's a little bit of a thinking problem, but you guys can handle it. Questions?